Hi students, in the previous classes we have discussed many problems of first type, that is manufacturing problem. Now in this class directly we will take some examples of transportation problems. Right. So we'll take the transportation problem. Now you read this question, go through this, try to visualize it. Here the certain information given, we'll take sentence by sentence and we will picturize it, right? The first briefly, it is two factories that are there located at P and Q. Second thing, certain commodity is produced in these two factories. Then there are three depots located at A, B and C. Weekly requirements of the depots, that is 5 units, 5 unit and 4 unit. And next thing, transportation cost per unit from P and Q to ABC, it is given in this table. Now finally, how many units should be transported from each factory to each depot in order that the transportation cost is minimum? What will be the minimum transportation cost? So summarizing this, let us take one by one. Here there are two factories located at P and Q, right? Factory at P and Q. Then there are three depots, that is A, B and located at A, B and C. Now weekly requirements of the commodity for A, B and C is 5 units, 5 units and 4 units, right? Then the production capacity of factory P and factory Q, 8 units and 6 units. So splitting each sentence, we are taking all the information like this, right, in this picture. We're trying to put it in this picture. Now production capacity 8 units and 6 units. Last, how many units should be transported from each factory to each depot in order the transportation cost is minimum? What will be the minimum transportation cost? Now we will start from here. How many units should be transported? Let X and Y be the units transported from P to A and from P to B. Now we cannot assume any other things because we are dealing only linear programming, that is linear equations, two variable. So we will assume X unit and Y units from P to A and from P to B. X and Y unit. Then now you have to think. Production capacity it is 8, requirement 5, X is given, Y is given to here, given to B. So total only maximum 8. So how much it can be for? How much can be delivered to depot C? It is X plus Y here. So the remaining, which is 8 minus X minus Y. 8 minus X minus Y. Now again you have to think this way. 5 unit is the requirement. X is already from P. X will be transported from P to A. So what, as per the requirements, how much it is required from B? From Q, it is 5 minus X. Then similarly, 5 unit is the requirement, Y is from P, so from Q it is 5 minus Y. Again it comes, totally two ways you can think of this X plus Y minus 4, two ways. First part, here all 4 unit is the requirement. X and 8 minus X minus Y is from there. From P, 8 minus X minus Y is already. So out of 4, the remaining it is 4 minus of 8 minus X minus Y, which is equal to that 4 minus 8, 4, the minus of X plus Y, that is X plus Y minus 4. Some other way also think of you in terms of 6 also, that is here 6 unit only the capacity to produce, Already 5 minus x and 5 minus y is taken. So 6 minus 5 minus x minus 5 minus y. So that also will be x plus y minus 4. So all this information we have put it in the picture, right? Now x, y, 8 minus x minus y, 5 minus x, 5 minus y and x plus y minus 4. Now see, some more additional information. Transportation cost per unit from P to A is 160. Here it is 100 and here it is 150. And again from Q to A, 100 rupees. From Q to B, 120, and from Q to C it is 100 rupees. Now using this, we have to frame the function to be minimized as well as all the linear constraints. From this, it is possible to frame everything. For example, the function to be minimized, transportation cost per unit, it is 160 rupees. For x unit, it is 160x plus 100y plus 150 into 8 minus x minus y plus 100 into 5 minus x plus 120 into 5 minus y plus 100 into x plus y minus 4. This is the total transportation cost. And this is the function to be minimized. Now linear constraints also, altogether we can say x must be greater than or equal to 0, y must be greater than or equal to 0, 8 minus x minus y must be greater than or equal to 0. Like that we have to take one by one after the other constraints. Right? Here, first constraint, x greater than or equal to 0. Second one, 8 minus x y greater than or equal to 0. Then third one, 8 minus x minus y must be greater than or equal to 0. Next, 5 minus x must be greater than or equal to 0. Then 5 minus y must be greater than or equal to 0. Then x plus y minus 4 greater than or equal to 0. That is the last constraint. So we have got, taking all these things into consideration, we got all these inequations. It is so clear. 1, 2, 3, 4, 5, 6, everything we have written. Right. Now we have to, before going to the transportation cost, you can see the constraint in a different way it is written. X greater than or equal to 0, y greater than or equal to 0, no difference. 8 minus x minus y greater than or equal to 0 can be written as x plus y less than or equal to 8. And 5 minus x greater than or equal to 0 can be written as x less than or equal to 5. And 5 minus y greater than or equal to 0, it is y less than or equal to 5. Then x plus y minus 4 greater than or equal to 0 is same as equivalent x plus y greater than or x plus y greater than or equal to 4. That we have taken in a different way. Right? Now, from this, we can calculate the function to be minimized, which is the transportation cost. How it is, you see. Already, that later we will take that function to, because a lengthy process is that we have to calculate it. Now we will plot the graph. First x greater than or equal to 0, y greater than or equal to x plus y less than or equal to 8. X equal to 0, y is 8. 0, 8 is a point. And 0, 8 is beyond, then some more points you can take. When y is equal to 0, x equal to 8, 8, 0. Then when x equal to 4, y is equal to 4. So 4 is another point, then the line, then x plus y is equal to 8 is this line. Then the second, next constraint, x less than or equal to 5. Here no need to plot the points and all. You know, x equal to 0 represents y-axis. And x equal to 0 represents y-axis. X equal to 5 is a line parallel to y-axis at a distance of 5 units from the origin. So directly you can write x equal to 5 is a line parallel to y-axis at a distance of 5 units from the origin. Now again, the next one it is y less than or equal to 5. Again, y equal to 0 is x-axis, y equal to 0 x-axis, y equal to 5 is a line parallel to x-axis at a distance of 5 units from the origin, right? So directly we have drawn the line which is y is equal to 5. Then one more constraint was there. It is x plus y greater than or equal to 4. Now x equal to 0, y is 4, 0 plus 4. So 0, 4 is a point. Then when y equal to 0, x equal to 4, 4 plus 0 is equal to 4. That is 4, 0 is a point. So we got 2 points. Draw the graph. Now we got and all the graph in the same paper. We have drawn. Now previously many examples we have taken how to find out each inequalities and region, right? Now this will be the common region. If you shade one after the other, this part will be the common region, feasible region. Now for that, one by one, first one in the same line, x plus y is equal to 8, x equal to 5, y equal to 5, x equal to 0, which is y-axis, x plus y is equal to 4, and this is x-axis, whose its equation is y is equal to 0, right? Now, which is the feasible region. Here, the shaded portion is the feasible region, satisfying all the condition, all these constraints, and this region, the points in this region will satisfy all these constraints, right? Now what is the next one? Corner points. Solving these two, we have to get the corner points. Solving y is equal to 0 and this line x equal to this one, x equal to 5. We will get this also already, and then the point is D35, then E05, then next last one F04. Here origin is not a corner point. In this example, the corner point of the feasible region, all the points we have plotted. Now let us go to function to be minimized, transportation cost. Let us calculate it. That is how to calculate the transportation cost. The function to be maximized is z is equal to, that is the total cost, right? It is 160 into x per unit 160 rupees for, so x unit 160x, then plus 100 into y, next plus 150 into 8 minus x minus y, and plus 100 into 5 minus x, then plus 120 into 5 minus y, right? Next, plus 100 into x plus y minus 4. So, all these things from P to A, P to B, P to C, Q to A, Q to B, Q to C, the transportation cost. You can take your own time and go through this, right? Now, this simplification gives you the function to be minimized is z is equal to, once simplification you will do later, I will go faster, 160x plus 100y plus 150, all these things it is written. Now simplified form 10 into x minus 7y plus 190. Simplification, it is so easy, you can do it later. Okay. Now what is the next step? At each corner point we have to find out the value of this objective function. Let us see that. These are the corner points of the feasible region. This is the objective function. And at 4, 0, let us substitute x equal to 0 and y is equal to 0. That 10 into 0, x4, 4 minus 0 plus 190. That is 1940. Similarly, you can do all this. You can find out the value of all these, value of the objective function at each corner point. Take your own time and calculate, because it's a very lengthy question. A lot of steps are involved in this, so it is prepared already, kept ready. Okay. Now, very clearly, minimum transportation cost is rupees 1550, and it is when at E05, that is 0 unit is transported from P to A, and 5 unit from P to B. Then the remaining you can calculate, right? Now from the table we see that minimum. This is the answer for that. This one already calculated and kept 0, 5, 3 from P, then from P to ABC, then correspond first one 0, 5, 3 from P, then 5, 0, 1 from factory Q. That should we go back and see. It will be this, x equal to 0, y is equal to 5. Here you have to substitute 8 minus x minus y, 3. Again, 5 minus 0, 5. 5 minus y, 5 minus 5, 0. X plus y, 0 plus 5 minus 4, 1. I told you, all these calculation you can do. Only x and y we got from the corner point at 0, 5. So the remaining value we have calculated. This is the briefly it is written in this graph, right? Now we will go to some miscellaneous exercise on chapter 12. Now see the first question. A fruit grower can use 2 types of fertilizer in his garden. Now read this question and we will split statement by each statement and we will analyze the problem. And all this information we will put it in a table. In brief it is, a fruit grower wanted to mix 2 types of brand fertilizers, brand P and brand Q, and in table it is given each brand contains nitrogen, phosphoric acid, potash and chlorine. It is expressed in kilogram. So per bag nitrogen content in brand P is 3 kilogram and in brand Q is 3.5 kilogram. Phosphoric acid 1 kilogram and 2 kilogram. Here potash 3 kilogram, 1.5 kilogram, 1.5 kilogram and 2 kilogram of chlorine. This is in brand P and brand Q. Now he wished to mix some bags of brand P and brand Q to minimize the amount of nitrogen. To minimize the amount of nitrogen he wanted. Such a way he has to mix. And there are certain conditions. We'll take one by one. Okay, now let us see. First, a fruit grower can use 2 types of fertilizer in his garden, brand P and brand Q. The next thing, table it is given, 2 brand P and Q. Then question it is, if the grower wants to minimize the amount of nitrogen added to the garden, how many bags of each brand should be used? So we will start from here. How many bags of each brand should be used? As usual, let x and y be the number of bags of brand P and brand Q used for minimizing the amount of nitrogen. Right? Next. So here x and mixture contain x number of bag of P and y number of bag of Q. Here x and y. Then the next sentence you see, test indicates that the garden needs at least 240 kilogram of phosphoric acid. That while mixing these 2 brands, that mixture should contain minimum 240 kilogram of phosphoric acid. Phosphoric acid is present in brand P as well as in Q, and here how much it is present it given. So for x bags, how much will be there, how many kilogram it will be there, we can take and at least 240 kilogram of phosphoric acid. Actually what is the amount of phosphoric acid? 1x plus 2y. Minimum 240 should be there. So but you can say here also comes less than or equal to, greater than or equal to. There I am concentrating minimum 240. It can be more than 240. That is x plus 2y greater than or equal to 240. Why I struck this point? In previous examples you were getting all the time we were getting less than or equal to region. Now here the word used it is at least a minimum 240 should be there and it can be more than that. So x plus 2y greater than or equal to 240. Next about at least 270 kilogram of potash. So it is 3x plus 1.5y greater than or equal to 270 because it is at least 270. So it is 3x plus 1.5y greater than or equal to 270. And about chlorine it is told at most, maximum it can be there, so it can be less also. So what we will frame 1.5x plus 2y less than or equal to, right? Because at most it is given in the question. At the most 310 kilogram of chlorine. So what is the next constraint? 1.5x plus 2y greater than or equal to, less than or equal to 310. So we got all the constraints, and again two non-linear, non-negative constraints are there. Now what is the next step? We have to question what is the minimum amount of nitrogen added in the garden. So the function to be minimized is amount of nitrogen. What is the amount of nitrogen? Per bag 3 kilograms. So for x bag 3x. Per bag 3.5 kilograms. So for y bag 3.5 into y. So total amount of nitrogen present in the mixture, it is 3x plus 3.5y. This is the function to be minimized. The function to be minimized is that is equal to 3x plus 3.5y. So we got all the constraints plus the function to be minimized, which is the amount of nitrogen present in the mixture. That way we have to mix P and Q. Now what's the next step? It is drawing the graph. Drawing the graph of each inequations. Let us take the first one, x greater than or equal to y greater than 0. It is in the first quadrant. X plus 2y greater than or equal to 240, x equal to 0, y is equal to 120. 0, 120 is a point. Then when y is equal to 0, x equal to 240, that is 240, 0 is the second point. Then the graph is x plus 2y is equal to 240. We got the line. Then less than or equal it is greater than or equal to 240. You see, x plus 2y greater than or equal to 240. So whether this region or this region, take the point 0, 0, substitute here x 0 plus 0, 0 greater than 240. First time you are getting one such example. 0 greater than 240. Is it so? No. 0 is less than 240. So origin is not in the required region. So this is not the region in this case. Origin is not in the region. So the other region x plus 2y greater than or equal to 240. So this is our required region x plus 2y greater than or equal to 240. The next constraint, what it is? 3x plus 1.5 again greater than or equal to 270. X is equal to 0, corresponding y value, it is 0, 180. Then when y is equal to 0, you will be getting 3 into 90, 270. So that 90, 0 is the second point. Then the line, this line is 3x plus 1.5 y is equal to 270. Again it is greater than or equal to 270. Substitute 0, 0. This is our new line. 3x plus 1.5, this is the new line. So one side and the other side to decide the region or origin 0, x equal to 0, 0 plus 0 greater than 270. 0 is not greater than 270. 0 is less than 270. So we conclude origin is not in the region. Origin is not in the region means this is our region. So in the previous case above this line, now this is the region. Again x greater than the first quadrant we have taken. Then now the next one, next constraint, it was 1.5x plus 2y less than or equal to 310. Here for plotting x equal to 0, y is equal to 155, right? So 0, 155 is a point. When y is equal to 0, what happens? Y is equal to here x is equal to 120 is taken. Calculation, I told you, you can select any point. Here instead of putting y is equal to 0, x is equal to 120, corresponding y value is 65. Then we got the line, third line, that is 1.5x plus 2y is equal to 310. Then less than region. Here this is the line here below one part, above one part. Substitute 0, 0, x equal to 0, y is equal to 0, 0 less than or equal to 310. It is 0 is less than 310. It is correct only. So origin is in the required region. So this is the region. So you see, for the first line, this one, for the second line, it is above, and for the first line above, for the second line also above, and for the third line it is below, and in the first quadrant. So this will be the required common region, which is the feasible region. Now let us take all the three inequalities at a time, and this region is the feasible region. Corresponding solving these two equations, you will get the corner point, and solving these two, you will be getting this corner point B140, 50, and solving these two lines, this corner point will be. Solving of equation and getting the solution point of intersection and all, it was in the previous classes, lower classes. That is why directly it is taken. Now what is the next one? We have to calculate the value of the objective function at the corner points. Corner points A 40, 100, B 140, 50, C 20, 140. At each point, substituting x equal to 40, y is equal to 100. The value is 470, 140, x 140, y 50. The value will be 595. X is equal to 20, y is equal to 140. 3x plus 3.5, y will be 550. So we got all the values also. Now, among the, what we have to minimize, the function to be minimized was amount of nitrogen, which is 3x plus 3.5y. Minimum value out of 470, 595 and 550, it is 470. Minimum value is 470. Now you may have a doubt why this 595. Next side, one more additional part was the, what is the maximum amount of nitrogen. In what way we have to mix brand P and brand Q. So here minimum value 470. When we take 40 bags of brand P and 100 bags of brand Q, if you mix, the mixture contains 470 kilogram of nitrogen, which is the minimum one. Now we will go to the next one. Here minimum value is 470. So 40 bags, what I explained already, right? 40 bags of brand P and 100 bags of brand Q, and the minimum amount of nitrogen is 470. Now here it's not a separate question. In textbook, in the miscellaneous exercise, it is 9. So refer question 8. If the grower wants to maximize the amount of nitrogen, it is easy from the previous one itself. Once again, it is 470, 595 and 550. Among these, 595 is the maximum value. Therefore, 140 bags of brand P and 50 bags of brand Q should be mixed so as the mixture contains 595 kilogram of nitrogen. So simple all these things. Maximization and minimization, the same problem. Maximum value of maximum amount of nitrogen and minimum amount of nitrogen from the same table, but under the same constraint it was. So we could do it as a part of this question. Right? Now a lot of problems are there. You can see here, toy company manufactures 2 types of dolls and all. It comes under manufacturing problem, you see. Finally, question levels of dolls type A can be exceeded 3 times. How many of each should be produced weekly in order to maximize the profit? Many questions we have done already for maximizing the profit function to maximize. So the same way, this you can do as homework. Right. Later, if you want, we will discuss in the next class.